All right, CNT120, Chapter 1. We just got done talking about our client server and peer-to-peer. So now we're going to look at how networks are used. In other words, some of the client server applications. So network services, the resources network makes available to its user. These are some of the applications we're about to talk about next. Some of the things that are available because of a network. So some client server applications. Client computer requests data, and the server is going to respond with that, whether it be a file or a web page or communication, those sorts of things. The server is going to respond to that and reply with that. Well, all of that is, I should say, most of that falls under the category of protocols. Protocols are the rules of communication. If I'm going to communicate a certain way, I'm going to use this protocol. Well, think of a protocol as when I drive on the road in the United States, we drive on the right-hand side of the road. That doesn't happen everywhere in the world, but in the United States, that's the way we do it. Everything's kind of designed around that standard. You know, the lines on the road and the road signs and the left turn arrows and the turn on reds, all that's designed around that protocol that we drive on the right hand side of the road. Well, in the computer world, if I'm going to communicate a certain piece of data, a certain protocol is going to get used. Example, if I'm going to download a web page or request a web page, that information is going to come in the form of an HTTP request, or I'm going to get an HTTP reply where I literally get a web page from the web server. So let's talk about a couple of these protocols. Now, before we do that, we need to introduce the idea of TCP/IP. TCP/IP is, for lack of a better term, a bucket of protocols. It's called the TCP/IP protocol suite, and I put a sample here. I put a picture here. This is just to introduce the idea to you. There is a bucket of protocols for different types of communication. If I want to move a file from A to B, I'm probably going to use FTP, that protocol. If I'm going to download a web page, I'm most likely going to use HTTP. If I'm going to send an email, I'm most likely going to use SMTP. Okay, so there's different protocols for different purposes, and these all serve a function. Okay, so think of TCP/IP protocol suite as literally a bucket of protocols that are going to get used to move certain types of data around. And pretty much our networks and our internet is based around using the TCP/IP protocol suite. Side note, once upon a time there were other buckets of protocols. IBM had its own bucket of protocols. Apple had its own bucket of protocols. Novell had its own bucket of protocols. And these would be, the IBM SNA bucket of protocols. The Novell IPX SPX bucket of protocols. Okay, so there were different ones. The world has kind of narrowed down and settled upon everybody using the TCP/IP protocol suite for our communication purposes, pretty much globally. All right, let's introduce a couple of these. We are going to come back in later chapters and dig into these more. So these are just kind of like get the ball rolling. Okay, so don't get too bogged down. Just kind of recognize the big idea. If I want to move data around, web data around, I'm most likely going to be using my browser communicating to a web server. And all of that communication is going to happen via HTTP requests, if you will. So I'm going to do an HTTP request to a server, and the server will respond with my web page. Now, plain old HTTP is not secure. There's nothing secure about it. It's all plain text, if you will. Along comes, a handful of years ago, if you will, HTTPS. The S on the end, most people think of that as secure. Okay, HTTPS secure. HTTP now has with it a layer of encryption, and it's usually either in the SSL or TLS, one of the two. A lot of times it's TLS, transport layer security. That is added on to HTTP to make the transaction secure. Well, you typically find that when I am, and actually here's an example of HTTP, here's an example of HTTPS. I typically find that for the longest time when I did any kind of financial or bank transactions. Well, most places have migrated that. My web browser even occurs HTTPS. Many places do that just for security's sake, to protect your communications back and forth. So if I even open my browser over here, my D2L HTTPS. Okay, right there it is, HTTPS. Another communication that we would have would be email. Well, email is typically going to have more than one server involved. My computer would format the email and send it to a mail server via SMTP, Simple Mail Transfer Protocol. It then would get relayed to your email server and sit there for you and wait. And you, when you log in, would retrieve your email via POP3 or IMAP4. Most places used to use POP3. Most places now use IMAP4. I'm not saying they all do, but most places have moved on using IMAP4. The subtle difference there is with POP3, and I think I have it here for you. POP3, you retrieve the messages from the server, and the messages are typically removed from the server. With IMAP4, the client computer retrieves a message from the email server, but the client manages the messages on the server. A lot of us know this because I might, on my phone, read the message and file it, and when I sit down on my laptop, that's already been filed for me. Okay, I'm interfacing my messages on the server. Okay, so my SMTP is the sending piece of my email. The POP3 or IMAP4 is the retrieving piece of my email, if you will. DNS, Domain Name System. DNS is there to help us translate a name to an address. This is the name to address translation service that helps us find a server. So if I want to load Formula1.com website, my computer doesn't know the IP address for that. So when I type in Formula1.com, a DNS request gets issued and says, hey, does anybody know the address of Formula1.com? And a DNS server, most likely on my network, responds back with, hey, this is the address of. And this might be close. This is in the ballpark. It's probably not 100% accurate, but that's the ballpark of what that address is. It responds back with that IP saying, hey, this is the address of the server you're looking for. Now my web request goes to that IP, that server, to request the web page be downloaded to my computer. So the DNS is here to translate my name, Formula1.com, to an address, 13.224. blah, blah, blah. That's what DNS is all about. Translate the name to address translation. And here I have just an example. If I sit down on my computer and I type in Amazon.com, the DNS server responds with an IP. I then make the request to that IP, and then the Amazon.com website gets sent back to my computer. That's how DNS functions. Most company networks have their own DNS server there to help with this. FTP, File Transfer Protocol. If I go back in time, when I've maintained websites, I would update my website through FTP. I would literally load the updated files to my website using FTP. This is very common, using programs like FileZilla, QtFTP, etc. The downside of this was not secure. These data transfers were clear text. You could read all the transfer as it occurred. Most places, if they use FTP to update websites and so forth, have moved on to using secure FTP, SFTP, secure FTP for moving files around. This is usually for large files. And I use the example of updating a website because that's commonly what people would use FTP for. And here's an example of FileZilla showing you the moving files from my computer up to the web server, if you will, or whatever it happened to be that I'm managing. Database, client-server application databases. Databases serve as basically a container for massive storage. Most websites on the back end have a database managing all that information. That's how if I go to purchase a brand new pair of sunglasses or glasses, it says, well, there's 3 of those in stock or 5 of those in stock. That website is interfacing a database to say, this is what we have back here. This is what we have in storage, if you will. Well, that needs to be maintained by a database system, database management system. And the programming for that is typically through SQL, Structured Query Language, SQL, SQL. Popular examples of SQL database are MySQL, Oracle Database, and open source MySQL. These would be some different database systems that you might run. Another client-server application would be remote access, remotely connecting to a device. If you think about, let me pick on Hack for a second. If you think about Hack's network, we have Lancaster, Lebanon, Gettysburg, York, Harrisburg. Okay, there's a lot of different sites out there. Well, if I'm going to manage all the network devices, routers, switches, etc., on all these sites, I'm not going to drive to all of them every day and check on them. I'm most likely going to be remoting into them to check on their functionality and or repair them. So remote access, I can remotely connect to a workstation, server, or network device for troubleshooting, management, update, repairs, etc. So remote access is a service that would be used to manage things on my network. An older style of remote access was Telnet. Most networks don't use this anymore because that information again was transferred in clear text. It was not encrypted, so all the data being transferred back and forth could be read. Most networks have moved on to SSH, Secure Shell. I still have access the same way. I can access a router and switch remotely, work on it, fix it, repair it, but that communication back and forth is encrypted. In our second level networking class, we learn how to set both of these up and use them. So we actually do a little bit of labs in them for remote access. Now, just for fun, let me show you real quickly Telnet here. I'm going to use a program. Let me start this guy right here. This is a program called Wireshark. This allows me to, and we are going to use this a little bit later this semester, this allows me to see data that's moving across my network and look at the data as it's moving. Now, side note, this is a program free to download that you can use on your home system, on your home network. Just do not download this on a work computer and use it on your work network. It looks like you're trying to compromise your network. Okay, just a little disclaimer there. All right, so I'm going to start capturing my traffic moving across my network, and then I'm going to open a little test site, and I'm going to go out here. I'm going to use Telnet, and I'm going to go to telehack.com, and I'm going to open the site there. And I've just connected into it. I've remoted into their little server, and I'm going to launch this program down here called Star Wars. Star Wars. And this is actually going to start playing a text version of the movie. And the cool part is my computer back here is capturing, my Wireshark back here is capturing all that. Well, if I let that run, it actually plays a whole bunch of the movie. I'm going to save us some time. Let's do a Control-C there, and I'm going to close that. That'll work. Actually, I'll do a quit. There we go. And now I'm going to stop my Wireshark, and I'm going to go look at a chunk of my data. Let me slide up here a good bit. Let's look at some of my Telnet data. And let's open this and take a look at. Here is the Telnet data that my computer captured, and it's literally showing that opening sequence. Yeah, this Telnet data is transferred in clear text. So most networks have moved away from this because, as you see right here, I've captured that and I can see exactly every character that was sent back and forth between that site and my computer. Just a little fun thing. Just so you can see that this is not very secure and has been replaced by SSH. SSH, if we captured it, would all be encrypted. I wouldn't be able to read what was there. All right. Another remote access that is useful is remote desktop. Remote desktop is a Windows thing that allows you to remotely connect to a Windows server or desktop, if you will, like you're sitting there on the computer to have access to it to either help somebody with an issue or troubleshoot an issue for that device. Very handy for managing devices in your network. And I would use this utility here to remote access to a certain IP address. And once I'm there, I would have access to, here's my actual computer back here, and then this is me remotely connecting to whatever that entity was, a server, another workstation, etc. Again, this is another lab that we do in our 125 class, doing some remote connectivity. We do remote connectivity with Telnet, with SSH, as well as remote desktop. All right, so there's a little bit about our network client server applications. We'll continue in the next podcast.